back. Another day, another lesson of Newton's laws of motion. It's James here. So today we're going to talk about Newton's third law of motion. First of all, to start off, let me start with the definition of Newton's third law of motion. To put it simply, Newton's third law of motion basically states that for every action, there's an equal and opposite reaction. But this statement could be ambiguous sometimes, right? Put in maybe chemistry. If I put salt in the water, that's my action. And as a result, the salt dissolves in the water, and that could be called as a reaction. So, if we're going into the world of physics, let me put a little bit more of physics elements in this statement. So for every action and reaction, they are equal in terms of magnitude, but they are opposite in terms of direction. So from what we learned before, we know we use forces to measure, express, or predict actions. So in this case, two objects apply a pair of equal but opposite forces on each other, which result in what we call as action and reaction. Therefore, Newton's third law of motion is also known as the law of action and reaction. At this point, some of you might wonder, wait a minute, that's not true. When I crack an egg on the kitchen table, nothing happened to the kitchen table, but the egg yolk is everywhere. How come this is equal but opposite? Well, let's find out in a video of me cracking an egg on the kitchen table, and then I will come back for further explanations. So here, as you can see, this is a complete egg, no cracks on it, and now I'm gonna crack it open. And now this is the picture after the egg is being cracked. Alright, coming back. As we see in the video, the egg is completely cracked open, but clearly nothing happened to the kitchen table. So what's the reason behind this? Well, this has to do with the effects of forces on different objects. Well, in this case, one object is the egg. The other object is the kitchen table, which is made of marble stones, which is pretty solid and very hard to crack open, right? So when the egg hits the table, although the table exerts a force on the egg and the egg exerts the exact same magnitude but in opposite direction, a force on the table, the effects of these two forces on these two objects are completely different. The eggshell is very thin, very fragile, so that force makes it crack open. But that force is not hard enough or great enough to make a crack on the kitchen table. So that's why you would perceive the phenomenon that eggs is cracked open but nothing happened to the table, and you think the table is much harder than the egg, and the force the table exerts on the egg is much greater than the force exerts by the egg on the table. Well, that's not true according to Newton's third law of motion, and we have to remember all these forces, as long as they're forces that one object exerts to the other, they are always equal but opposite. Well, with that being said, let's watch another video I found on YouTube, which is a physics professor from USC. He conducted a very cool demonstration of Newton's third law of motion, which he fires a fire extinguisher to make him slide on a skateboard. So now let's watch it. that's a pretty cool demonstration, right? So if we have to apply Newton's third law of motion into that demonstration, how are we going to explain it? Well, here's how. So no matter what's in that fire extinguisher, it's either gas or some powder. When the valve was released, the gas in it or the material in it was pushed forward, and as a result, the material exerts a backward force on that professor, which makes him slide backwards on that skateboard. So with these two demonstrations, the egg and the fire extinguisher, we can conclude another key point in Newton's third law of motion, which is there can never be a single isolated force. Forces always come in pairs. In the egg and kitchen table scenario, there's two forces. One is exerted by the egg onto the kitchen table. The other is exerted by the kitchen table onto the egg. Well, similarly, in the fire extinguisher case, there is a force exerted by the material in the fire extinguisher on the professor, and there is also a force applied on the material, which is forward. So with that being said, that concludes all the key points we need to know about Newton's third law of motion. I hope you enjoyed today's video and enjoy your day in the world of physics. This is James. Thank you for watching.